So I'm going to talk about measurement mass data capture technology a little bit and use some examples to explain some of the things that we've been doing and hybrid processes, which I'll explain later. Right, to start with, so what we do in my team, we do engineering simulation and we model existing structures. And we use all sorts of tools for that, and we need geometry to do that. This, in fact, was never built. It was a 1,000-foot-high masonry tower by Jules Bordeaux in the late 19th century. Came second in the Eiffel Tower competition. The Eiffel Tower got built, this didn't. And we was asked by a TV company to speculate on what might have happened had they tried to build it. We don't believe they would have had the foundation technology to really pull this one off. But really, this movie and this one as well demonstrate the power that we can bring to bear in terms of modelling these things. The software here actually was developed here at Swansea, Elvin, and we've been using it for quite a few years now to model masonry kind of structures. What that's actually showing there, that the red is where we've got high compression. So quite recently, I was involved in the Manchester hub, and that red line is now a new railway alignment, which actually cuts off the world's oldest railway station, which is a bit controversial. And for that, we was asked to look at the arches again, and these viaducts were being modified by removing spans and then putting in concrete boxes and things like this. And we did this simulation just to say, well, if you do that and you don't really kind of design it, then it could be a bit tricky. And if they had lost a number of spans, then the railways in Manchester would have been closed for years. Now, normally you wouldn't use such powerful methods for this kind of work, but it's just that the consequences of it going wrong were so great that we had to look at this in quite a lot of detail. I suppose that was the project that brought us into contact with laser scanning for the first time, because up until about 1998, so a long time ago, a year into this project, we were using table stations and things like that. It's quite manual, moving targets around, things like that. And then in 1998, we teamed up with UK Robotics for a short time. So this is about a couple of years before the big surveying companies really got going with scanners. And they turned up with a thing that looked like it ought to stay indoors and scanned a bridge. And it was an interesting data, kind of in the wrong place, didn't really work very well. But it showed the potential. And then from then on, really, we've been using 3D scanners to capture geometry. And we're keeping an eye on the technology that's coming along. We've got one of these ZNF 5016 images next door. There's the Leica offerings, handheld systems, 3D cameras emerging, all sorts of stuff. That picture of that silver dime there, the chip on there is a LiDAR chip, which is a part of the components that goes into cars. These things are being mass produced now because of autonomous stuff. I think what's going to happen is that we're going to see better instruments, longer ranges, more accurate, cheaper, high frequency measurement because of that industry. So there's lots to look out for there. The Nikon thing in the middle there is something they use for when they build aircraft, and that allows you to position things within a factory to within 1/100th of a millimeter. It's quite extraordinary. It costs a fortune. Not good for our industry really, but it just sort of shows you where this technology is and where it's going. We try to keep in touch with what's going on. 3 or 4 years ago, we did a sort of UAV test flight down in our Southampton office, and this was really to compare the results of digital photogrammetry with 3D laser scanning to see how good it was really. And so, well, obviously UAVs and drones are around a lot now. They're great just for inspections, which is what's going on here. What we're interested in really here is, a set of photographs with good geometry to produce point clouds. And what we're doing there is comparing the coloured point cloud there is the one from digital photogrammetry, and the red and the blue is from 3D laser scanning terrestrial stuff. And we compared the whole lot and then did a few spot checks. And now I suppose this exercise was a little bit like a lab test, under ideal conditions, but the few spot checks that we did were, way less than 10 millimeters, so really quite spectacular. So these are just some examples of how it has tended to be used. So point cloud on the left-hand side, a CAD model on the right-hand side, just surfaces, rights of light kind of calculation, and that's what that was used for. So it's just 3D geometry, it's not BIM, it's just surfaces. Another example of how this data is being used is, to produce drawings. So we've got a point cloud top left, we've kind of taken a slice through it and removed perspective bottom left, and then we can scale that, pop it onto a drawing, and put a few vectors over it for dimensions, and you get to the end product, in this case a historic building, faster than the traditional ways of doing it. Plus you get the benefit of rendered surfaces. So, if you're really interested in where the joints are between stones, then, it's there. And of course to create 3D models, so which then feed into BIM, so it's geometry. It can also introduce the object properties, wall thicknesses, pipe diameters, things like that. Lots of scope here for machine learning, really, spotting things in point clouds, perfect application. That's just traditional BIM. Got to be real careful of that when you're looking at existing structures, because tools like Revit kind of assume things are, vertical and sort of horizontal and that sort of thing, regular cross sections. The top right there is Q actually, and it was useful, but it was a bit over idealized, and some of the guys working on it had an interest in historic structures, were not sort of overly pleased with the sort of compromises that were made by somebody down the line in developing that model. Once you've got these point clouds, you can do all sorts of things with them. So this is actually looking at a railway tunnel and checking escape routes. Red means you can't get out of a train, there's not enough room. Blue means there might be enough room, and green means there is. And this is just simply kind of processing the data, really. So we're not counting up or doing anything at all. We're just color coding the points to report a significance. Of course, once you've got that, we can mock up a train and sort of do a little simulation of what it would look like to escape from a broken down train in this tunnel. So this was some work that we did in association with the building of the Shard of Glass, and it was really looking at London Bridge Station. And the Shard of Glass, well, the construction sequence was knock down a 26-story building, dig a hole 4 stories deep, put on it a 75-story building. Now, the process that we're really interested in, and we've used quite a few times, this was the first time we used it, was to go kind of from point cloud to surface model to solid model to finite element mesh to structural analysis and strength assessment. And this little movie just takes us through that process. So this is the point cloud, so this is the bit that was measured to start with. And then we put a surface model onto that, which is what's going on there. It becomes a solid model, so this is where SI information goes in there to give us kind of, member thickness and things like that, depth of foundations. If we do that properly, then meshing is automatic. It's pretty straightforward. And then once we've done that, we can put it around, put loads on it, pull the ground about, that kind of thing, calculate, stresses, strains, displacements, and then compare that with, the material parameters to know whether that's an issue or not. And a more recent example of working that way was when we was asked to do a strength assessment of the Iron Bridge. And so the first thing, again, is we need really good quality geometry. The specification for this was to aim to laser scan it with a terrestrial sort of system, 95% coverage, ideally 2 millimeters, something like that. And then you think, well, hang on a moment, on a hot day that bridge is bigger. So, there's issues. It's quite complicated to achieve really good accuracy. And the next stage is to create a surface model. The main span we did fairly rigorously. So we've got surfaces that are all kind of joined up and mathematically defined. And then the sort of side spans, that was automatically meshed. And that was more for kind of visualization. So this is the visualization of the process. That's the point cloud. RGB data mapped onto it this time. That's the surface model. So the main span's done very rigorously. Side spans are meshes. And now we're just sort of panning around the arch. So that's the point cloud. That's the surface model, which is precisely in the same place. That's the finite element mesh as solids. The red bits are where we've modeled defects. And that's some arbitrary locus, and that's plotting, by the looks of it, displacement. But we could be looking at stresses or anything else, really. And just going back to the reason for using solids, those plots at the bottom there are cross-sections of some of the ribs. So that the bottom ones are internal, the top ones are external. And they're not eye sections, they're not hollow square sections. They are quite unique. So going through the point cloud, solid kind of route saves us time and is more accurate, really. And of course, the other thing about point clouds is you can see things you can't see in reality. So for example, we can produce this plot at the top there, which is the underside of the cast iron deck, looking at the individual plates. Well, you can't really get into that position in reality because there's things in the way and you'd never get a complete shot of it all. And then once we've got that, we can kind of look into it in a little bit more detail, which is the bottom there. And there we can see a crack in the deck plate. But it allows you to look at any sort of data set. So to start with there, we was looking at the point cloud, but now we've introduced the kind of solid model. And again, it's just like Google Street View. You can hop from place to place. It will run on any browser, on any device, and narrow bandwidth is what I would say. It's all about pre-calculated data. So this will run on my phone in here as well. Here's an example of an historic building. On the left-hand side is some fairly precise 3D laser scanning work with RGB mapped onto it. And on the right-hand side is exactly the same views. That's using our little viewer, but showing the CAD model. And I've highlighted the areas where there's significant difference, which may not be important, but they might be. And actually understanding what you're going to get out of that model is so important. To talk to the potential client, how it's going to be used. It's more than just saying, oh, LOD 200 or whatever. You really need to understand how this data is going to be used. So to address that kind of thing, we also got in this document and this piece of research working in a hybrid way. And this is where we don't CAD up the point cloud. So you just leave that alone. And then you only, in effect, CAD up new stuff. It's a bit like that example that I showed you kind of earlier on. And then, again, set out the kind of LODs that would be required and the kind of survey types that would be needed to achieve those. Another recent project is we've been working on HMS Warrior. But what we have found really useful is, so that's the environment that Dan would be working with, is to actually link into it the 360 views, so that little bit of software that we've written. Now, the way this normally works is that you have two screens. So you have this thing on one screen, your CAD environment on the other, and then those links, objects in the BIM model that automatically take you back to this thing. And then in this environment, you can switch between content. You can measure if you want to. But actually, it's really useful just to be able to see what it is you're trying to do. It's a great way of kind of being there virtually. And that's me done. Thanks very much.